Let's get started. This is section 2.5, finding implicit differentiation. So here you will be given an equation like this. So the task is to solve the given equation for dy over dx. So basically you are finding dy over dx for given problem. Okay, so look at this example 1. So you'll be given this formula. So the thing is now use this equation to find dy over dx. So basically we follow these steps to find implicit differentiation. First, look at the problem and look at the things whatever you want to find. So remember here you need to find the derivative of function y with respect to x, right? That means you need to take the given equation and differentiate the given equation both sides with respect to x. Okay, so you need to find the derivative with respect to x both sides. Okay, after finding that, you need to simply solve the given differentiation equation for dy over dx. Okay, so look at this problem. So the question is finding dy over dx. So you simply find the derivative with respect to x for each and every term. So both the side you are taking the derivative with respect to dx, with respect to x, sorry. So term by term finding the derivatives. So the first derivative, remember what is the derivative of y cube with respect to x? You could use the chain rule you learned last time. Use the chain rule to find this. So basically could use like a substitution. This is like u. So you have simply u cube. Okay. So the derivative of u cube with respect to u is 3u squared. That is 3 u is now y. So 3y squared. Then chain rule says that after taking the derivative with respect to y, then you have to take the derivative with respect to x because you are finding the derivative with respect to x, right? So now I'm going to find the derivative of y with respect to x. So this is coming from the chain rule. Okay, so we call the chain rule we learned last time. Okay, so you have to do this thing for all the terms one by one. Okay, so the first term, the derivative of y cubed with respect to x is 3y squared times dy over dx. All the time you have to, put the derivative with respect to x because you are finding the differentiation with respect to x, right? So if you use again, of the power rule, for this guy, the derivative of y squared with respect to y is 2y. But because of the chain rule, you have to take the derivative of inside function y with respect to x. Okay. So now the third term, y is constant, negative sign is here. So you simply find the derivative of y here, which is dy over dx. Okay. But here you don't find the dx component because the given function already in x, right? So you are finding the derivative with respect to x as well. Therefore, this is simply the power rule says that the derivative of x squared is 2x. Okay, that's why you see here negative 2x on minus 2x. Okay, this side you see the constant part, and if you take the derivative of the constant, negative 4 is always going to be 0. So this is the answer you see after finding the differentiation both sides with respect to x. Question is finding dy over dx, right? Now what you want to do is you have to combine all dy over dx terms. After that, you have to solve the equation for dy over dx. Okay, so these two steps doing that. So combining all dy over dx term, and you see here dy over dx, and the only thing is here you don't see dy over dx. So simply you are moving that term to the right side, and you are combining all dy over dx. So factor them out, dy over dx, then you will see this, and you are solving for dy over dx. So divide both sides by 3y squared plus 2y minus 5. So this will be cancelled, and you will get simply dy over dx as 2x over 3y squared plus 2y minus 5. The thing is, here you have to keep in mind that if you find the derivative with respect to any function in terms of y, this is nothing but f prime y, then dy over dx. This is true for any function, okay? So you'll be given a function inside in terms of y. So simply take the derivative with respect to y, then times dy over dx. Okay? Here, question is finding the equation of the tangent line. First of all, you need to, find the slope of the tangent line. Simply, you are finding dy over dx, right? Slope means. But you need to find the dy over dx at the point 1, 1. So again, you use implicit differentiation here. Differentiate the given equation by with respect to x. Okay, so do like d over dx of both sides. Simply I'm taking the derivative with respect to x both the sides. Okay, now you need to find the derivative term by term. So the derivative of 4 with respect to x plus the derivative of xy. Then this side you could find the derivative term by term. First term, then subtract d over dx of second term is x, then plus d over dx of 2. Okay, so again, as I said earlier, you see now this is like a function fy. So take the derivative of y to the power 4 by using power rule, which is 4y cubed. But inside function y, derivative is dy over dx. Remember, you are taking the derivative with respect to x, right? Here you have to use the product rule because you see two functions multiplying with each other. So remember the product rule. What is that? We call the product rule. D over dx of f times g function is f times g prime plus g times f prime, right? I'm using this formula for the derivative of the product function. So that's going to be x times dA over dx of y plus y times d over dx of x, right? So I'm using the product rule here. And this side is simply power rule. The derivative of x cubed is 3x squared. The derivative of x is 1. And the derivative of 2 is constant 0, right? So if you simplify, you will get 4y cubed plus, 4y cubed times dy over dx, then plus x times dy over dx. Then here you will get dx over dx is simply 1. So you will get simply y times 1, which is y. Okay, that side you see 3x squared minus 1. Now, like earlier, you have to solve for dy over dx. So combine these two. Take dy over dx as a common factor. So the leftover is 4y cubed plus x. Okay, so now move this y to the right side, and you will get that is 3x squared minus 1 minus. Then dividing both sides by this guy will give you dy over dx. So that which is 3x squared minus 1 minus y over 4y cubed plus x. That's the answer you get for dy or dx. That is here. Okay. So now remember, you are finding the slope at the point 1, 1. So simply plugging x1 and y1 here to get the slope m at that point 1, 1. If you're plugging 1, 1 here, you will simply get 1 over 5. That's going to be the slope of the tangent line. After that, you know how to find the equation of the tangent line using y minus y1 equals slope times x minus x1 formula. You know the point, so that is x1 and y1. Okay, simply plugging m is now 1 over 5. Okay, simply plugging everything here and rearrange them, so you will get this answer. That is there. Example 3 also, you are given an equation, but the thing is, you need to find out the second derivative, right? Remember, y double prime means the second derivative of the function y with respect to x. This is the meaning, right? So first find y prime. Y prime means dy over dx. After that, again, one more time, take the derivative to find the second one. That's what here. So you find the derivative with respect to x first. So let me write down the equation. This is the equation given one. So y squared minus xy equals 8. First, you need to find y prime. Remember, y prime means nothing but dy over dx, right? So let us find dy over dx by differentiating with respect to x both the sides. So first guy, we need to take the derivative with respect to x of y squared, then the derivative of x for xy, then the derivative of the constant h. Again, I'm using the chain rule. The derivative of y squared is 2y, but inside function y derivative is dy over dx by using the chain rule. Here again, use the product rule like earlier we did here. The same work, right? So d over dx of xy, I got the answer here. I'm simply copying this part here because you don't need to do again. So which is x times, I see minus sign here, okay? dy over dx, then minus y, okay? Because of this minus, you will see two minuses here. So this is basically 0. Now solve this equation for dy over dx. Simply take dy over dx as a common factor. So I see 2y here, and here x is left over. Then minus y equals 0. Then remember, we are solving for dy over dx, so I'm moving negative y to the right side. So you will get dy over dx, which is times 2y minus x equals y. Now divide both sides by 2y minus x. So this is gone. So you will get dy over dx. Remember, that is y prime, no? Which is y over 2y plus x. The one you have here. So this is y prime, right? Question is finding y double prime. So one more time we are taking the derivative by using, quotient rule, because you see now two guys like a fraction. So you have to use the quotient rule to find the double prime. Okay. So take the derivative of this guy one more time with respect to x. So use the quotient rule. So the derivative of top times bottom minus the derivative of bottom times top over bottom square. So this is coming from the quotient rule of the derivative. So you learned earlier. This is quotient rule. derivatives. Please recall them. So after that, um, just a simple algebra and using and simplifying. Okay, so let me know if you can understand this. Just simplifying by using algebraic techniques and solving the equation for y prime. Okay, is there? So remaining problem solve like that. So you have to first find dy over dx, solve for dy over dx. Then if you are asked, d2y over dx2, again one more time take the derivative. Okay, so all the work is here done. So you just go through and let me know if you have any questions. Okay, so this is again one problem you are given. So this is the given equation, right? So the question is find dy over dx. So basically you are going to use so many rules. Okay, first using the chain rule, then power rule, and plugging them inside, and you will get this expression. Okay, so how did you get this step? Okay, I will show you that step. This is the given problem, right? So simply take the derivative both sides with respect to x. Write down one more step. Okay, so simply you are taking the derivative with respect to x both the side. Now, constant is here. You could pull the constant. Okay. This side also I see 25 constant. Pull outside. Now here you could use the chain rule. So this is, you could think of like function y or u, but you have the square here, so you could use the power rule here. So you have more work now. So if you use the power rule, this is like, you could think of like this is like u squared. So the derivative of u squared is 2u. U is here x squared plus y squared. 2u times du over dx, right? The chain rule says. So I have to find the derivative of inside function, which is x squared plus y squared. Okay. So this 2 is here using the power rule. So what I'm doing is here, please go through the chain rule. I just let this guy as u. I'm using u as inside function x squared plus y squared. If it is u, then this is nothing but u squared. So the derivative of u squared is 2u, but it's like u. But the inside function should be differentiated with respect to x, right? That's what I'm doing, that is here using the chain rule. Okay, now that side, let me change the color. So that side, 25 is their constant. Now take the derivative term by term. So the derivative of x squared, then minus 25 times t over dx of y squared. Okay, here 2 times 2 is 4, x squared plus y squared. Then again, term by term derivative will give you d over dx of x squared is 2x plus d over dx of 2y squared is again a power rule 2y times dy over dx. This side 25, the derivative of x squared is 2x. Subtract 25, the derivative of y squared is 2y, but again change rule dy over dx. Okay? Remember dy over dx is y prime. So if you plug in here y prime and simplify this guy, you will come up with this term. This term. So remember, we all know that y prime is nothing but dy over dx. If you plug in y prime for dy over dx into this expression, so you will get that, right? That's 2x plus 2y and y prime. This side 25 times 2 is 50, but x. Here also 50y, but this is y prime. That is here. After that, solve this equation for dy over dx and make sure that you get this answer. So they are asking again the slope of the picture landscape. Then they are given the points and simply plugging x and y values to find the slope. Okay, so only thing is you have to get practice about using chain rule. Okay, use the chain rule and find the derivatives implicitly. That's the work you have to learn. Okay. That is about 2.5. Okay, so now I'm assigning some problems. I already uploaded all the work problems. So why don't you go through them? Let me check. From your textbook, why don't you try these problems? From the text, web design. Do problem number 16. I already uploaded all the work problem for these. But anyway, you need to first try, okay? Then question number 30. Please try these two problems and make sure that you get the answer. Okay? It's all about implicit differentiation. So if you look at 2.6, here nothing but we apply differentiation technique to do some problem related to rate of change. Okay, rate of change. So this is the idea you have to follow to deal with rate of change problems. First, you need to draw the picture to get better understanding. Then write down the given values of any variables and rates of change given in the problem with respect to time t. So you need to set up an equation, which relates the variables. After that, use the implicit differentiation, the one you studied in 2.5. Then make use of that implicit differentiation to, identify the last step. Okay, this is very good example. So look at this example. So at a distance of 12,000 feet from the launch site, the spectator is watching a rocket being launched vertically. What's the speed of the rocket at the instant when the distance of the rocket to the spectator is 30,000 feet and is increasing at 480 feet per second? Okay, so this is one real application, of implicit differentiation. Question is finding the speed of the rocket, right? At the instant where the distance of the rocket from the spectator is 13,000 feet. So you could think of like this picture. This is the point where the spectator is. So the vertical distance is y, and the horizontal distance is x. At some point, rocket is here. Okay. So if you draw a right-angled triangle, always we could find the relationship between z, y, and x by using Pythagoras theorem. So this is the relationship, right? Okay. So now this is the distance, spectator is watching. That is 12,000 feet, right? Okay. So the question is now, we need to find, right? We need to find what? Read the problem. We need to find the speed of the rocket. Okay. The rocket is launched here, going vertically. So this is the distance of the rocket after some time. So the question is now finding the speed of the rocket. Another word, it is dy over dt, right? So you need to find dy over dt. Okay, so simply use the Pythagoras relationship here. Z squared is equal y squared plus x squared. So, so if you use Pythagoras theorem here, it says z squared is equal y squared plus x squared. Now you know x, the distance from the spectator and the rocket is, the launching place is x, which is 12,000 given in the problem. So if you plug in that into this formula, you will get 12,000 squared. Okay. Now question is finding the speed, so you have to find now dy over dt. That's your task. Okay. So basically, you take the derivative with respect to t, both the side. Okay, so if you take the derivative with respect to t, both the side, you will get the derivative of z squared is 2z, but inside function chain rule says dz over dt equals 2y times dy over dt. This is constant, so the derivative of constant is 0 here. So you get this. Okay, but the question is finding the speed when the distance is 30,000. So you simply plug in 13,000. So you will get, y in terms of, z, but we know z is 13,000. So this step coming from where? Coming from this relationship. Remember, you are finding dy over dt. That is your task. Okay. This formula is here. You found 2c times dc over dt equals to y times dy over dt. So if you simplify further, what you'll get? I could cancel 2. If you solve this equation for dy over dt, then so dy over dt is nothing but, you could divide by y both sides to get dy over dt. So dy over dt is nothing but z over y times dc over dt, right? So now basically you need to find this guy. That's the question. Where? When z is 13,000. When z is 30,000, you have to find y as well, right? You see here y. How do you find that? Simply use this relationship. You know the relationship between z and y. When z is 13,000, plug in here 13,000 and will give you, y. That is why here it says. Okay, plugging 30,000 here and solve for y. So you will get y. That is simply 5,000. So once you know y, simply plug in 5,000, z is 13,000, and the dz over dt is given in the problem, which is here 480. The rate of change of the rocket distance, okay, that's given from this vector test, it's given. So plugging all the values here, you will get dy over dt, which is 1248. So similarly, all the real life applications are here. So I just suggest you to go through this and try to understand all the steps. Okay. There are plenty of worked problems here. Simply you go through and make sure that you understand. Okay, so if you have any problem, please let me know. So no one is here today, so I'm just writing the problem for you guys to work on this section. Could you do problem number 20? Okay, you need to try this one. And problem number 29. And try these two problems, okay? And if you have any trouble, please set up an appointment with me so we could talk, through this Microsoft team meeting, or if you want to meet me in person in the office, you are always welcome. So remember, we are going to have a class test 2 on Monday. I already have uploaded practice test and the solutions for that. So please go through everything and let me know if you have any questions, okay?